All right, now we're back. All right, so really quickly, again, slope is kind of like the steepness. We said it's rise over run. We said it's the rate of change in y over change in x. There's also a formula that you learn, which you will use again next lesson. Actually, it wouldn't be y, it'd be m.
MX.
No, that's, you guys always want to say that. That's the equation of a line. M in that equation is the slope. But the equation for just slope is this one. Remember this one? The good news is when we get to that lesson, you don't have to memorize it. It's on your formula sheet, your reference sheet. So that's the big equation that you learned a long time ago. But again, the main thing I want you to understand is it's really just how steep the line is. So I have 3 different lines there. They're different steepnesses. But here's the couple things you need to understand about slope. So if I have a line that is going from board is driving me crazy to this. So I can tell you already I'm frustrated today, and I'm already hearing people talking through my lesson. That better stop fast. Right, Logan?
What?
Read. Don't even know what I just said. It wasn't you today. All right. There. Yeah, this board has been doing this all day long, which is frustrating. So I'm itchy. And I'll tell you right now, this could potentially be your easiest quiz of the quarter. So if you blow it because you didn't put any effort into it, I'm not going to feel bad about it for you. Again, I told you I would tell you when we got the easy stuff, and I'm telling you right now, this lesson's easy relative to other. I'm not saying it's overall easy, but relative to the first 2 and what's probably going to come up later, this is a quiz where if you put effort into it, nobody's get below an 80. Nobody. All right, now hopefully that works better. So if I'm a little better, so if I'm a little tiny ant guy, and if I start on the left, fantastic artist. If I start on the left side of a line, and if I walk the line, if I'm walking down the line, again, if I walk that blue line, I'd be going down. That line has a negative slope. If I'm on a line and I walk up, so now I'm on the red line. I don't know why it keeps doing that. If I'm walking up the line, that line has a positive slope. So what's the slope of the green line? Negative or positive? Positive, right? If I were on the left, even though I'm really, really walking up, that's a positive slope. I'd be going up, left to right. The second piece of slope is the actual number part. So that's the sign of it, positive or negative. The number part has to do with how straight up and down it is. So for this green line, that's pretty straight up and down. That one might have a slope of 2 or 3. Where's my? It's positive, we said. So maybe 2, maybe 3, somewhere in that range. I didn't draw the numbers in, but somewhere in that range, 2 or 3. This red line is pretty flat. Oh, the x-axis or a horizontal line, that's got a 0 slope. There's no slope, it's flat. So if you're walking on the ground, ground's flat, there's no slope, it's not a hill. Only things that are hills, either up or down, have slope. Flat, no slope. Straight up and down is undefined. We'll get into that later. So the red line maybe has a slope of like 1/3, 0.3, something like that. Again, positive because it's going up, but it's very low. It's close to being flat. The blue line, again, it's negative, so down, so negative. But it's a little steeper than this. It's steeper than the red. Well, it's not super steep because, again, if it were really steep, it'd be like a 3 or a 4. It's probably like, it's not a 1. I'd say it might be like
2.5.
Well, no, it's definitely lower than that. It's not even 1. Like it'd probably be more like a 1/2, because 1/2, if you don't know, 1/2 is a bigger number than 1/3, and it's a little steeper than 1/3. It might be 3/4, but again, if you think of decimals, this one's about 0.3. This one might be about 0.5, maybe 0.7, something like that. So again, the steeper, the more straight up and down it is, the higher the number part. And then you just determine if it's going down, left to right, it's negative. If it's going up, left to right, it's positive. So that's like a super fast review of slope, which you did multiple times. Should have done that. And if you had pre-algebra, you did it in pre-algebra, and then you would have certainly done it in algebra as well. All right. So with that in mind, our lesson today is about a very specific topic, which is why it's pretty easy, because there's only one real concept you have to get from this one. And I'm not going to be doing proofs, I don't think, from it. There are proofs in the chapter, but I'm not going to put any down. So turn to page 181. So get your, not the ones we just tore out, the ones that we had before that. So it was like 163 to 190. Shut up, bro. 163 to 190 is the packet. You're turning to page 181. It's the last lesson in the packet. I think it's 3-6.
Oh, these papers are ready.
Yeah, as far as old pages, I don't go back and use old pages. So unless you're gonna like review for the midterm, you don't need anything from. Well, you need this last packet, which I guess we technically did tear out in the fourth quarter.
What page?
I think it's 181. If that's the beginning of a. Have all this pages. It was part of 163 through 190 was the section we tore out. After we tore out. Oh, actually, here I have it. I can tell you for sure.
163.
Well, that was the packet. If you stapled them, that would be the first page. But if you didn't staple them, it shouldn't matter. Yeah, 181. Looks like that. 3-7, parallel lines, transversals.
Oh, no, he ain't give you a crack there.
There you go. Hear any rustling on? Oh, a couple people still looking. I'm going to go ahead and start while they're looking. So I'm not going to do a lot with, definition stuff on this quiz. It's not like some of the other quizzes where it was a lot of memorization. You need to understand what I'm talking about. But I really don't use the word skew lines a lot. I'm hoping that's not something that pops up. You do need to understand that parallel lines are shown, because remember, I think I told you this. You don't know for sure two lines are parallel unless they tell you that somehow. Well, if I just drew two lines in, I said, there, those two lines, are they parallel? You'd have to say no. Say, I haven't given you any information that tells you those are parallel, even though they look close to parallel. They have to either tell you this, so that little symbol, again, I mark it in your books or in your pages, that symbol means that the two lines are parallel, or line segments or whatever. Normally it'll be two line segments. The two straight up and down lines pretty close.
It's a black line.
Like that.
6 period.
Oh, did it say a time on it? I didn't look at it. 29. All right. The other way they can tell you two lines are parallel is in the figure itself. Those two little markings, like they look like, the ends of an arrow, basically. Those tell you that those two lines are parallel. And it doesn't always have to be filled in and colored in. Sometimes you might just see this. It'll be in the middle of the line somewhere. So not the ends of the arrow don't matter. So if they also had arrows out here, normally they'll make them different in some way, like these will be darker or something. But if you have two little arrow marks in the middle of the lines, it's telling you those two lines are parallel. But you have to understand that because then that determines whether you can or cannot do some of the math calculations we're going to do. Let's see. What's another? And I guess the only other way they might tell you they're parallel is just in words. They may say line S is parallel to line T in words. But somehow you have to be told lines are parallel to do some of what we're going to do in a little while. All right, so now go down. Oh, so we do need to go over this. So you need to know what a transversal is. If you have two lines, and they don't have to be parallel, so that line and that line, clearly not parallel. If I draw a line through those, that black line is called a transversal. It crosses two lines. I mean, it could cross more than two, but has to cross at least two lines to be called a transversal. So that's what that word is that I just circled, transversal. That will come into play a lot. Again, I'm not going to quiz you on what is a transversal, but I will say the word transversal a lot when I refer to the line that is crossing the other lines. But if you don't know what it is, and every time I say it, you're like, what is he talking about? You're going to be in trouble. So make sure you remember, memorize, whatever you got to do. The one single line that crosses the other line is the transversal. So that when I use that word, you'll know which line I'm talking about. These lines don't really have a specific name, the two red lines. If they're parallel, well, we would normally say the two parallel lines, but if they're not parallel, we don't really have names for the two lines. And I think that's it for that piece. So now look down here where it says transversal angle pair relationships. So I'm going to use a lot of these terms. Not going to quiz you on vocabulary, but I'm going to say them throughout this entire lesson today. Probably next lesson, we'll still be working on a little bit of this stuff. So you need to understand what I'm talking about. What's the word interior mean? Just interior.
Inside.
It means inside, right? So if we are talking about interior, we're talking about inside the two lines. So those angles that are inside are interior angles. So if they're not interior, what do you think they're called? Yeah, so for exterior, they just mean the other angles that are outside the line. So 1 and 2, 8 and 7 in this particular drawing. Now, there's some specific things that happen with interior and exterior. We have what's called alternate or alternating interior. Alternate, what's alternate mean? Or alternate, maybe a better way. It means that you're kind of going back and forth. Like if you alternate things, you're going back and forth between them. So if that helps you, the English definition of it, in this particular concept, alternate means they're on the opposite sides of the transversal. It alternates sides. One angle is on one side, the other angle is on the other side of the transversal. So 3 and 5 would be alternate because they're on opposite sides of the transversal, but they're also on the interior, so they're interior. So alternate interior. So when I say that stuff, even if you haven't completely memorized things, you should be able to figure it out. Like again, interior means they're inside.
Exterior. 2 and 8 and 1 and 7.
Yeah. And it's always in pairs. When you say I can't say alternate interior and you just pick one. It's got to be like alternate interior has to have a pair of angles that have that relationship to each other. So 3 and 5, well, I mean, it says it all over here, but 3 and 5 are alternate interior, 4 and 6 are alternate interior. Alternate exterior would be the 1 and the 7. Again, they're on opposite sides of the transversal. So the transversal is the single line. 1's over there on the left, 7's on the right, and they're exterior because they're outside the two lines. And then corresponding is the only, I feel like, only slightly tricky one because there's nothing that really, at least not to me, there's nothing that matches with the name as to where the angles are. One of them is interior, one of them is exterior. So they'll never both be interior, never both be interior. So again, 5 and 1 would be corresponding. So same side of the transversal. 1 is interior, 1 is exterior. And they can't be next to each other. I can't say 1 and 4 are corresponding. So they can't be next to each other. So 1 and 5 or 8 and 4. I mean, again, they're all right here. That's corresponding. And you definitely need to know those last 3. Consecutive interior doesn't come up as much, but 4 and 5 be consecutive interior. I mean, again, they're really just interior on the same side as opposed to alternate interior. And there is a special relationship we'll go over with those, so you kind of need to know them. But knowing the relationship as far as what equals what have the same measures, what two add up to 180, that's really what you need to know for the quiz. But for the lesson part, I'm going to be using those terms, so you need to know it, be able to follow along with what I say. Any questions on any of that vocabulary stuff? We went through it pretty fast, but I am hoping that even on the district stuff, they don't really just make it a vocabulary quiz. I can't see that. I hope it doesn't happen. All right, so next page. All right, so again, since I didn't spend tons of time on vocabulary, I'm not worried about example 1. Go ahead, though, and really quickly classify the angles. So do example 2. Didn't take long. If you need to go back to the page before, go back to the page before. Were you here? Yes. You were? Mm-hmm. I think I already said this, but was anybody not here yesterday? Right. I'll give you another minute. Like I said, if you need to go back to the page before, figure out or what the yeah. Somebody put it back in the wrong spot. Oh, she is? Yeah. She said if she didn't do well, we should really know what's basically happening. Other teachers other than maybe one, we think she can get that one specific teacher. Other teachers aren't really needed. Plus she hasn't done anything. So you should be wrapped up. So as soon as I check the keys out,
You'll move on to the check.
yeah. If you want to go ahead and do the check, that's fine. I'm gonna just do this page now. Do that. Go ahead. You can always move on. You don't ever have to wait if you want to do the check. Or the next example. All right, so actually, I don't even really need to be at the board. You have it in your books. So angles 4 and 5 are what? Does everybody agree with that? Alternate interior. Yeah, they're inside and they're on opposite sides of the transversal. Alternate interior. Angles, what are the next two? I can see 3 and 7. What are they?
Corresponding.
So yeah, they're corresponding. They're on the same side. One of them is inside, one of them is outside, one is interior, one is exterior, and they're not next to each other. So that's corresponding. 3 and 5 are what? Yeah, that's the one I told you wasn't super important, but you could use the pages before. Consecutive interior. Again, they're both interior, and we know they're not alternating interior, so they have to be consecutive interior. What's that? Again, I don't even think the district is ever going to have you like need to know the vocabulary. The reason you need to understand it is because when I'm going through and saying the two alternate interior and I'm doing the lesson, you need to know which two I'm talking about because there may not always be numbers. 1 and 8 or what? Alternate. Yeah, you can say alternate exterior because you have a bunch of just like 1 and 2 are exterior, but they're not alternate exterior. So 1 and 8 are alternate exterior. Let's see. If you want to do the check problem real quick, we can do the check problem. We'll just do it up here. If you didn't do it in your book, that's fine. 1 and 5 or what? So again, they're both outside, so they're definitely both exterior. One's on one side of the transversal, one's on the other side. So alternate exterior. 2 and 4. So again, one's inside, one's outside. Same side of transversal. They're not consecutive because consecutive are both inside.
Oh, yeah.
So they'd be corresponding. I'm going to skip example 3.
Right.
All right, so let's go ahead and go to page 183. Now we're getting into the real core of the lesson, what you're going to wind up doing on quizzes, basically, or the quiz.
Right.
So here's, hang in for this. This is the part you have to see. This is the quiz. So when you have, what are those lines? What do they tell us in that figure? 2 parallel lines, right? We went over that. That's what this little arrow in the middle of the line is saying, that those 2 lines are parallel. Let's do this real quick. That's 183. So we said slope is a measure of steepness, but we also said there were some formulas for slope, right? So if I have this red line, for example, if I want to figure out the slope of that red line, there's a bunch of ways I can do it. I'm going to do it pretty quickly for you up here. I'm just going to count. I'm just going to count rise and run. I can say, and I need to kind of make sure I'm right on integers. Like I don't want to pick a point like right here on the red line because I don't know what number that is. I don't know what number it is on the x-axis. I don't know what number it is on the y-axis. So I wouldn't pick that point. Now, technically, you don't really know what any numbers are, but I can be pretty sure this point right here is probably 0, -3. I can be pretty sure this point right here is 1, 2, 3, 4, 5, 6, and then or -6, +1. Like it's close enough to the corners where I can be pretty sure. So if I want to figure out the slope, I need to go. I do the run first. Don't do the rise first. Do the run first. I know that's the way you learn it is rise first, but then that messes you up when you do this another thing that you do in geometry. So I'm going to say 1, 2, 3, 4, 5, 6. And then I'm say, okay, well, 1, 2, 3, 4. What is the slope of the red line? Positive or negative? Negative, right? So I don't even really need to worry about are these numbers positive or negative. I just need to know the slope of the line is negative. So my rise number is going to be 4, 6. I know it's negative, so I don't care which one is negative, the 4 or the 6. Well, if I reduce that, which you should, the slope of that line is -2/3. Now, here's the important concept in this parallel lines thing. So my slope is always relative to like a horizontal line, right? It's relative to the x-axis, really. Well, it doesn't matter where that line is. This line always has a slope of -2/3. I could find the slope down here. I could say, well, what if I went the other way? Well, 1, 2, 3, 1, 2. So it's negative 2/3.
So you do run first?
Always do run first, mainly because if you do rise first, then you get it confused when you go to put points on a graph. So it doesn't matter where I could slide that line way over to the graph to the far right, it still have the slope of negative 2/3. The slope never changes unless the line actually twists and becomes steeper or flatter. So what that means is this angle that's created between the red and the blue line is the same angle that's created by the red and the blue line down here, right? Because the slope of the red line doesn't change. These two lines are parallel, so they have the same. Oh, by the way, the only way two things can be parallel, they have to have the same slope. Like if they had a different slope, then eventually they would meet because they'd be a different steepness, right? Something that has a slope that is not the same as this would eventually get closer and closer to that line in one direction. So you need to make that note. In order for parallel lines have to have the same slope. We don't get into that a whole lot in this lesson. I think it'll probably come up later, but I could see that being a district thing for sure. Two lines, actually the next lesson we do get into it quite a bit. Two lines that are parallel have to have the same slope because otherwise they're not going at the same steepness and one of them is eventually going to run into the other one. So if I'm crossing two lines that are parallel, I'm hitting those two lines at the same angle. I could even sort of show that. Well, from here, I go over 1, 2, 3, and up 2 to get back on the line. From here, I could say I go over 1, 2, 3, and then up 2, and I'm back on the line again. So like, it's the same angle that gets created if a line goes through two parallel lines. Transversal goes through two parallel lines. So, what's important about that? Oh, yeah, we'll do it. That's fine. So again, that red and blue line are parallel. I didn't really show you that, but I'll show it to you now. And since my board sucks, I'm going to have to fix that. I've already tried to fix it like 6 times today. There, close enough. So those two little arrows show that the lines are parallel. So if those two lines are parallel, and if that means that when I cut through them, I create angles that have the same measure, there's only two different measures of angles in that. So let's say, actually draw that figure. I want you to try to do this first. Let's see how far. So draw that just two, as close as you can get to parallel, and then draw a line through them at the same, kind of angle. If I tell you this, and I want you to do this on your paper, don't yell it out. If I tell you that's 40 degrees, I want you to tell me as many other angles as you can in that figure. There's 8 total angles, so 1, 2, 3, 4, 5, 6, 7, 8. I want you to tell me as many as you can in your figure. Write it like don't tell me. Write it down in your figure. See how many you think you can get. Write the actual measure of the angles. Give you like a minute to do it on your own. Yeah, it is full. Or we'll do it together. Oh, did I do it? Actually, too, I'll do attendance while you're doing that. Then by the time I finish attendance, yeah, I don't care if you talk it out. Like anytime we're doing lesson, I encourage you to work together really on. Just make sure you understand it. Don't just have somebody tell you what to do. That's not going to help you on a quiz. Certainly, you could compare answers. I'd always do that. Oh, let's see. No, Evan, it looks like. Evan, David, Azir, David, Isaiah, Jacob, Sarah, Rhea, Ronaldo's here. Trisha, I saw. Yeah, Vicky's on a field trip. She's still in here. Did you hear me, Sarah? She's just on a field trip. She's not. Well, she said if she didn't do well, again, I don't know what she thinks she's gonna do. Like, she's not gonna find it any easier. And well, there is one teacher that might teach her. She's got to take geometry. She can't get out of geometry. Right, so looks like everybody else is here. Let me try. Oh, I don't know if this is gonna work. It's broken. Hopefully you have that drawn. Let me do this real quick. See if it'll fix it a little bit. Like the 12th time I've done it. All right, so raise your hand if you got at least one other angle. Raise your hand. Nobody else? Wow. You guys are, that's going to be where we eventually end up. Raise your hand if you have your phone out and you shouldn't. There, you fixed it. Raise your hand if you got at least two other angles, so 3 total, including the 40. 4, 5, 6. Oh boy, 7, 8. So it seems like if you guys got one, you pretty much got them all. If you didn't get one, I don't know what's that. Well, it's like wow, that was hard. We went over vertical angles. What's vertical angles mean? What are vertical? So they're. I don't love up and down because I wouldn't really think of 40 and its vertical angles as up and down.
Oh no.
Huh?
Interesting.
What's again? I told you vertical angles is one of the most important ones, and it would be the one you forget. And then the next one's the one you've all forgotten too. You didn't get any angles. You've got to know these two things. They're going to be through the rest of geometry off and on. What is true about vertical, or what are vertical angles? Ava, what are vertical angles? See, this is when I get really upset. We've been over this a million times. Like, we just did proofs on vertical angles last week. Find it hard to believe that you guys can't retain stuff. If you tried, like if you had studied a little bit for quizzes, done the practice problems, I just don't think anybody in here can retain it. Because I watch y'all do your TikToks and you retain that after about the 300th time of doing it. You're more than willing to practice that stuff 100 times, but you won't look this stuff over twice. So again, you get out what you put in. Drives me crazy when you guys put nothing, unless you just don't care. But then admit, don't complain about grades and, oh, it's too hard. It's either priority or if it's not. If it's a priority, you'll be fine. If it's not, then don't complain. Just say, yeah, grades aren't a priority for me. Just guys, that's vertical angle. If you have, remember, it's a slightly different drawing because I just do that, but it's just an X. If you ignored all of this stuff down here, it'd be the same thing right there. Angles that are across from each other are congruent. I don't love the up and down thing. They're across from each other. So 40 and 40 should have been automatic angles for people. What else do we know about some angles up there where those 40s are? If I have two angles that make up a line, we've said. If I can draw a semicircle through the two angles, that's 180 degrees. So here's what we did again, nothing new. I drew a line, I said, how many degrees in a line? And then I said, so if I do this, did I change how many degrees in that line? So that must mean this angle, angle 1 plus angle 2, have to add up to 180. Not equal, they add up to 180. Because again, the original line was 180 degrees, and I didn't change that line. I just split it into two angles. So 1 plus 2 has to be 180. Well, if I know that, then what do I know about where we'll say this 40 is up here? They got to add up to 180, right? So that means I can solve by just saying 180 subtract 40. That one's 140. And now I can go ahead and say, well, I already know. Or I could have said this 40 plus this has to be 180, or this 40 plus this has to be 180, because they would both be on the black line. Or I could do vertical angles. Again, a lot of different ways I could get to 140 down there. Well, now we get to those relationships we just learned a second. So here's where you do have to take the new, that's old stuff. We learned that and they've done that multiple times. Now, though, we have to say, well, wait a minute. I just learned if I have parallel lines, I have a whole bunch of relationships. Name one relationship we just learned. Miles, you name it. Yeah, what kind of angles did we learn? Like, what kind of relationships did we just learn? When we have parallel lines, or actually don't even have two lines that get cut through by a transversal, we just learned a whole bunch of names of types of angles. So we learned alternate interior, right? Alternate interior means they're inside the two lines, so inside the red and blue. They're on opposite sides of the transversal, which is the black line. And what's true about alternate interior angles? Isaiah, what's true about alternate interior angles? You and Logan are doing a lot of chatting and stuff. So that must mean you know everything. What's true about alternate interior angles?
Vice versa.
Oh, yeah, I held you. Oh, we're almost done.
Okay.
Either of you. Again, this is the issue. I moved you guys over there to try to make it better, but.
That they're alternating.
For what? So what's that mean? What's important about the fact that they're alternate? I already said they're alternate interior. What's important about that?
So opposite sides.
Well, but you're telling me, but what's important about it? You're defining it, but I need to know why are they important? Why do they have their own name practically? Go back and look it up. Look up alternate interior angles for look up the one for parallel lines. It's actually the next page. So it's on the same page we're on.
Yeah.
If it's cut by the.
I just did it when I did the graph and I had two parallel lines. Like I did it when I did the graph. Well, we do have that. Go ahead.
Aren't they going to be? They're going to be like one side of the truck for
Yes. So he just. So alternate interior, we said, are congruent angles. Or you could have also said if this transversal goes through, we said that when a line cuts through, it creates two angles that are the same. So this 40 would have to be that 40. We just did that on the graph when I did the two parallel lines. Somehow, though, you should have known this 40 or this 40, or you could have said that 140 and that 140. You just needed one of them from up here to like be able to say, oh, well, I know this angle is the same as down here. Now what can we do with that 40 on the bottom? Yeah, we do the same thing we just did up top. So that's 40. Well, if those are 40, these have to add up to 180. Same thing we did up top. So how many different angles did we actually have? Like how many different measures?
Two.
Just two. And that will be the case. Anytime you have two parallel lines cut by a transversal, there's only two different measures. So you just got to figure out how to set up the problem. Oh, yeah. This is the majority of the quiz. So here's your two options. Either, since there's only two different measures, there's only two different options for setting up an equation and solving for a variable, which we'll do in a minute. Either you're going to set the angles equal, because if you notice, there's a bunch of 40s. Those angles all equaled each other. They were vertical angles up top with each other. These two were vertical down below with each other. But then you had alternate interior. You had corresponding, like you had a bunch of angles that were equal to each other.
It's gonna be like that every time.
The other, yeah, anytime again, the key is that they're parallel. That's what has to happen. If they don't tell you they're parallel, can't assume that all of this happens. Got to be two parallel lines that then get cut by a transversal. The other, what did I do, blue? So the only other option is what? Either they're equal to each other or what? Congruent is equal, so
Yeah.
we're use that. So what's the other option? If they're not equal, they have to what? How did we solve for the other ones when they were equal? How did we solve? We had 40. How did we solve for 140?
Fraction.
So
From. So either they're equal or they add to 180. That's it. That's why I say it's pretty easy lesson. You just got to figure out, do I set the two things equal to solve, or do I add them both together and set them equal to 180? So you're going to do a more complex problem in a minute where you'll kind of see where we're eventually going. But for now, actually, I'll just make one up real quick. Anybody still writing that? Anybody writing first place? Many. You can go now. I got to pass. I had to pass. They not bring it back? I think somebody forgot to bring it back last class. Oh well. What's today? 24. All right, so here's the baby step to where we're eventually going to go. I want you to tell me I want you to solve for x. Solve for x. Again, you got two options to set an equation up. Give you like 3 minutes. Feel like that should be enough time. I'm going to figure it out. If you're not going to figure it out, and I don't want to wait forever. But solve for x. Mainly, you need to know how to create the equation. That's the most important part, although this is pretty easy. Algebra also. Creating the equation on the quiz, kind of back to what we did in some of the other quizzes. If you could just create the correct equation and all your algebra is wrong, you get a C. That's an equation, but not what we would use here. An equation means you have a left side and a right side and an equal sign in between. That's the only way you can solve for a variable is to create an equation. You don't have an equation like that equals something, because again, the fact that we have an equal sign that tells us the left side equals the right side, that's what allows us to solve, because we know one side has to equal the other side, so we can figure it out. You'll see when I do it. I'm not sure about it. Just try to solve for x. Tell me what x is. I made the numbers pretty simple, so you can probably just sort of figure it out, even if you can't create the equation.
Yeah, so it's like,
Again, just for now, I made the numbers easy, so you could solve it even if you couldn't create the equation. But
It's solved.
keep in mind, on the quiz, they won't be, you're going to see it. You're going to see an example in a minute of pretty much exactly what you're
Do we have to put x plus 10 or can we put one thing?
right now, just solve for x. If you don't know how to create the equation,
The diagram, like the equal for the vertical line, do we put x plus 10 or do we just put
I want you to solve for x.
Okay.
Again, however you need it. If you think that works, do it. Again, I want to see where we're at. If I tell you what to do, then I'm not seeing where you're at. So I would just want to see what people do on their own. If everybody gets us right, then I'm like, okay, we're in good shape. Nobody gets it right, then I know we're not in good shape. But if I tell you what to do, then I don't know where you're at. Yes, yeah, I see what you're saying. I didn't see the right hand person. All right, so again, we have two options when we have the measure of two angles, and we're trying to solve using those two angles. Either we set them equal, or they add up to 180. You just got to figure out which one is the case. So your first question is, well, does that angle equal 150? Is there something I've learned that would tell me, like alternate interior, alternate exterior, corresponding? Is there some relationship that tells me this angle equals that angle? Like, is there a relationship between those two angles, like the ones I just mentioned? What corresponding? Is that what corresponding means? Because you may want to look up corresponding. Corresponding would be on the same side of the transversal, which those are not. So it wouldn't be corresponding. Is there any relationship? There's only three relationships, really. Corresponding, alternate interior, alternate exterior. Well, asking you guys. Are they both exterior?
No.
Can't be that, right? 150 is interior.
Oh, okay.
So there's your first hint. One angle's interior, one is exterior. So they can't be both alternate interior or both alternate exterior when one's interior, one's exterior. So that doesn't work. Corresponding doesn't work because they're on opposite sides of the transversal. So here's the thing, there's no relationship that we can come up with. Or the other way you could do it is say, well, relative to this angle here, what other angles are 150? Just tell me that. So we know that one, right? That's an easy one. So this top or this top? This top?
Yeah, the first one. The first one. That one.
That?
Yeah.
I'll make sure I was hearing right. So again, we could have said it was alternate interior also, because right, alternate interior would have been that's 150. So you could have put that 150 in a bunch of places. Now you should pretty easily be able to tell me what is true about the 150 and the x plus 10. What's true about them? What has to be the case? They have to add right because they're on the same line. They're both on the black line. If I look this way, they're both on that black line, so they have to add up to 180. I could also say they're both on the blue line, right? So they have to add up to 180. Well, then that's the equation you said. So we do struggle sometimes to create an equation. Oh, didn't mean that. So again, I just say, well, one angle plus the next angle has to add up to 180. That's what I mean by creating equation. And then if you do the math, you'd add the 150 and the 110. I'm sorry, and the 10, 160, subtract 160 from the 180. X would be 20. So that's pretty simple algebra there. It will get tougher on some of the other problems. And the logic, I guess, the concept does get a little tougher, not much tougher. I mean, mostly it's the algebra that gets tougher, but if you just understand, you've got to have some angles that have the same measure. I could have filled in every angle if I wanted to. Let's see if this works. Yeah. So I could have said, well, let me just fill in every single angle with everywhere I know. And then I'll worry about what equation later. I could have done that. Could have filled in everything. Because we just did it, right? We did it before when I gave you the 40, we filled in every single angle. I can do that if they're not numbers, if they're just variables. I can do that same thing. Then I might find it easier to set up the correct equation. All right, so here's the last level of difficulty, and then I'll let you do the example on your own. At the very least, again, hopefully you can set up the equation. I'm going to try to make these numbers work out. So let's say 2x plus 15. And then let's say I'm going to make this 5y subtract 10. I don't know. I may have to fix that number, but it should work. And then let's make this 10x. I think that's going to come out pretty nice and round. So I want you to solve for x and y. Really quiet on that. That's about as difficult as it'll get on the quiz, right there.
This always be like one question.
Yep. Uno.
What are we doing?
But again, if you can do that already, you're in good shape for Monday. I mean, we got another lesson on Thursday. So again, at the very least, you should be able to set up the equations. Now, there's one thing you need to remember. If I have two different variables in one equation, I can't solve for either variable. I don't really want to do that. I want to try to do something else first. I want to keep the same variables in the same equation, like just one variable in an equation first. So that's your first hint. I'll give you another hint in a minute. What I'm saying is don't try to put x and y in your first equation if you can't solve it.
But you can put the two x's.
Mm-hmm. Mm. I don't know if it's really going to work for. Oh, it's not going to work. Wait.
It is.
Actually, yeah, it just won't come out nice and round. I don't think. The y may not come out to be a nice round number. X will. Actually, no, y does too. But that was an accident. But what would you like? Freak them out.
Will we set them to equals to each other?
Oh, that's the question you got to ask yourself. What's the relay? If you need to fill out every single angle with the variable expressions first to know what you do, then do that. Like figure out where you can put like what would go in every other angle with just like those two expressions, then figure out what your equation would be. Don't worry about solving. Don't tell me answers yet. Not out loud. You can write them down. I'm gonna look at them. Although it would tell you the truth, it wouldn't really matter, I guess. Just hearing the answer from you. They still have to. Oh, that's right. I always struggle to read your lines.
Oh, I'm just gonna start doing lines. That's just a habit.
It always looks like a 2 or a 7 or something else to me. But assuming it was a 1, then yes. You're that stuck, you're in trouble for Monday. Because we're not doing this Thursday. We'll go on to a new lesson Thursday. So today's the day on this one. So let's start by just filling in other angles. Tell me something I can fill in. This one? This one.
Yeah.
All right. So I could say that's corresponding. Same side. I could do that. So this one would not be 5y
It's not.
because it's not alternate interior, it's not alternate exterior, it's not corresponding. These are corresponding actually here. Those two are corresponding, which means they're equal. But the problem is setting them equal doesn't do me any good because I'd have two variables in that equation. I can't solve. I actually have enough right now to solve. I mean, I could still say, I'll just tell you the one I would have jumped to maybe 2x plus 15 there. But I really don't need that. But so what you should know a relationship right now that you're like, oh, I can set an equation. If you didn't do anything before, now the light bulb went on. Go ahead and set up an equation. I'll give you a minute to try to finish up. You gotta move on. I'll give you a hint. All right, so why not just draw in the rainbow thing? Those two angles added together have to equal 180. That's your equation. And there's only going to be one variable, so we'll be able to solve it. So that angle, so that's the angle on the left, plus 2x. So here's the angle on the right. Again, don't freak out when there's a variable and numbers in an angle. This is just some number. We just don't know what it is yet because we don't know what x is yet, but it's just some number. This is some number over here. This is some number, and it's actually going to be the same number as that, which we're going to eventually use to solve for y. But they're just numbers. So we write everything that's in one angle in x plus 45 plus everything that's in the angle next to it. And they have to add up to 180 because they are on that blue line. Now do the math. 12x. I'm going to do a short version of it because I'm running out of a little bit of room. So I add the x terms, I add the numbers, which is 60. All I did is I added the x terms together and I added the numbers together. Now I subtract 60 on both sides. Whatever I do on one side, I got to do on the other side. 12x equals 120. So x equals 10. So now what do we do? We're not done. How? What do I need to do?
Wait, no.
Typically, if you solve for a variable and you're not done with the problem, yeah, you're going to use the information that you just learned. You just learned x is 10. So I don't need x anywhere. I can give myself numbers in all of those now. So what would I do? How do I use the fact that x is 10?
Fill it in.
X, like, 2 times.
Yeah, absolutely. You could solve for every angle. You could plug in 10 everywhere for x, because if x is 10, x is a variable. It is an unknown number when we start. If we know the number, we would rather have the number there than the variable. So I could take all the x's out. So that angle is 35 degrees. So I don't need this anymore. I know what that angle is. I don't want variables if I can help it. Like, I'd rather get rid of it. That's why we try to solve. So that angle is 35 degrees. But what do we know about that angle relative to this angle?
That they're the same.
Yeah, it's corresponding, right? Those are corresponding angles. So that means this has to equal what? So that's my equation. Now solve for y.
This is all the test is gonna be.
From today's lesson. There's a lesson on Thursday. But I told you this was going to be, again, I'm not saying it's easy right now, but I'm saying once you get this down, the problems are exactly like this. Unlike in the other stuff, there I can give you an infinite. I mean, I can give you an infinite for these two technically, but they'd still all be the same. The other stuff, there was just like every problem could be different than the other stuff. Proofs, every proof could be different. You'll use some of the same reasons, but
Is this right?
well, what'd you get? Just tell me. Correct. So we would add 10, add 10. Whatever I do to one side, I do the other. Oops.
Cross out the 10, drop down to 5 and the y. 45 and then divide it by 5.
So you should have gotten y as not. Divide by 5, divide by 5. If you don't know, I got for the last step. So that's the most complex thing you'll see on the quiz from this lesson.
I just think I didn't understand how to screw it up.
Well, you'll see problems like that one in the book, so you're going to have some. Actually, I gave you a ton of practice problems. I gave you 37 problems to practice.
Oh,
You just need to do the ones you need to do. Like probably the first 20 of them won't be on the quiz. But there are things you need to understand for when I do lessons in the future, so I just assign them to you. You may know them all already, but just in case, I didn't want people to skip over those if they haven't started to really get the concept down. Where's my book? Oh. So go ahead on your own before we move on to the problems. Try example. Oh, shoot. Actually, turn to page 183 real quick. I can show you one more thing.
page what?
183. It's not super complex.
I already have that out.
Oh, I didn't mean to do that. Yeah, you might already be there. Like, that's what we were just on. What? Oh.
What page is the practice?
Well, let me show you this first, and then you're going to do the example problem on your own. If you have two perpendicular lines, what's perpendicular mean?
They.
Yeah,
Yeah, remember all the bricks are all perpendicular. You see a million right angles and somebody drew on my wall. So, I don't know who did that. So, if you have two perpendicular lines and you get one right angle, really, they didn't even need to show you that one. If you know that you have one right angle because you have perpendicular lines, then every angle is 90. Because the one across from it has to be 90. Well, the one next to it has to be 90 because they have to add up to 180. Well, alternate interior means that has to be 90. Down here, well, that means all these have to be 90 then. So again, if one angle is 90, they're all 90. And that's how you know that the lines are perpendicular, is because one of the angles is 90, which means every angle is 90. Oh, this is the symbol. I forgot to do this in last class.
What is that?
That's the symbol for perpendicular. So parallel is A and B. Perpendicular is T. So either A or to B. Because T is perpendicular to A and it's perpendicular to B. So if it's perpendicular to one parallel line, it's got to be perpendicular to both. The angle will be the same, just like we talked about before with transversals. Anytime you have two parallel lines and you draw a line through it, it's going to have the same angles between both of the two parallel lines. Like these angles have to match up with these angles if the two lines are parallel, which they are. So anyway, you can do the math on it and figure it out too. So not, hopefully it's fairly intuitive, but if not, I think most of the time you'll be able to figure it out using math anyway. Now though, you need to do the example, I think it's 5. Yeah, there's a bunch of proofs. I said I'm not going to put proofs on. They're not even as much proofs as they are. They're just going through and yeah. So number 5, do example 5. Kind of example 4 is an easier version. If you struggle on 5, you can try 4.
Where do you see that?
Or you can do. That's probably 186. 186. So if you can do example 5. It's not the hardest thing that will be on the quiz, but it's the second hardest thing that will be on the quiz. So you can at least do that one. 186. Example 5, 186. There's no second angle you have to solve for. They only have you solve for the x, just one variable. But the algebra is similar to what we did a minute ago. Actually, I'm just going to tell you the problems too. So again, here's what you're responsible for from this lesson for the quiz. What I did, so that one most complex one that I showed you, the X and Y one, but then the practice for you will be example 5, and then page 187, 1 through 37. But again, like I said, the first 20 are all super basic. If you want to skip them, you can, if you feel like you understand them already.
So I know.
Yeah, it won't take you long. I mean, some of them, like I said, you're just naming angles, like alternate interior, alternate exterior, like it's not complex stuff. So the stuff that'll be on the quiz will be the problems that you'll get to later in the practice.
187.
187, 1 through 37. Correct. And I'll tell you more like on Thursday specifically which problems.
So what do we think?
Like I can already tell you number 30 is one you're going to want to do. But that's like what we just did a minute ago with an X and a Y in it. Also number 31. So 29 through 31, you may want to put an asterisk by. 29 through 31 are pretty similar, which you'll see in the quiz. I'm going to put that up on the board also. The whole set is example 5 that I said on 186, but then page 187, 1 through 37, 29 through 31 are like the very similar to the quiz question also. And there'll probably be one like explanation maybe where I don't know how to go. We'll see.
Bro, what's that one paper down?
Yeah, actually, oh yeah, we got 18 minutes. I forget how fast that clock is. Is it?
Yes.
There's a vent right above you.
Yeah, that vent does when it turns on.